Welcome to this introduction to integration in calculus. In this video, we're going to learn what integration is, how it relates to finding areas, and how to calculate basic integrals. So what exactly is integration? Integration is represented by this symbol, which is called an integral sign. It looks like an elongated S, which comes from the Latin word summa, meaning sum. At its most basic level, integration is a method to find the area under a curve. Let's consider a simple example. Finding the area under the curve of f of x equals x squared, from x equals 0 to x equals 2. One way to approximate the area under a curve is to use rectangles, which is called a Riemann sum. Let's divide our interval from 0 to 2 into 4 equal parts. We can then draw 4 rectangles, where the height of each rectangle equals the value of the function at a specific point in each subinterval. As you can see, each rectangle approximates a portion of the area under the curve. The sum of the areas of these rectangles gives us an approximation of the total area under the curve. If we increase the number of rectangles, our approximation becomes more accurate. As the number of rectangles approaches infinity, this sum approaches the exact area, which is what we call the definite integral. Mathematically, we write this definite integral as the integral from a to b of f of x dx, where a and b are the lower and upper limits of integration. For our example, we're finding the integral from 0 to 2 of x squared dx. To evaluate this integral, we use the fundamental theorem of calculus, which connects differentiation and integration. The theorem states that if we can find a function capital F whose derivative is the function f, then the definite integral equals capital F evaluated at the upper limit minus capital F evaluated at the lower limit. This function capital F is called the antiderivative of f. Finding antiderivatives is a key part of integration. Let's learn some basic integration rules. First, the power rule. The integral of x raised to the power n equals x raised to the power n plus 1 divided by n plus 1 plus a constant c. This works for any power except negative 1. For example, the integral of x squared dx equals x cubed divided by 3 plus c. Second, the constant rule. The integral of a constant k equals k times x plus a constant c. Third, the sum rule. The integral of a sum equals the sum of the integrals. Let's go back to our example and solve the integral from 0 to 2 of x squared dx. Using the power rule, we find that the antiderivative of x squared is x cubed over 3 plus c. Applying the fundamental theorem of calculus, we evaluate this antiderivative at the upper and lower limits. The result is 2 cubed over 3 minus 0 cubed over 3, which equals 8/3, or approximately 2.67. So the area under the curve of f of x equals x squared from x equals 0 to x equals 2 is 8/3 square units. Integration has many practical applications beyond finding areas. It can be used to calculate volumes, average values, work done by a variable force, and probability distributions, among many other applications in physics, engineering, economics, and statistics. To summarize, integration is a fundamental concept in calculus that allows us to find areas under curves and solve many other important problems. We learned that the definite integral represents the area under a curve, and we use the fundamental theorem of calculus to evaluate integrals by finding antiderivatives. We also covered some basic integration rules, including the power rule, the constant rule, and the sum rule. Integration is a powerful mathematical tool that builds on what you've learned about derivatives, and it opens up many new possibilities in applied mathematics. Thank you for watching this introduction to integration. Practice with simple functions to build your skills, and soon you'll be solving more complex integration problems with confidence.